Okay, let's go ahead and begin. My name is Jason Marshall, and this program is called Inspire Science. So this will be a short presentation about Inspire Science and specifically how the program is structured. What are some of the components in the program that will assist in-class, remote, or hybrid learning? And what makes Inspire Science unique? So as I've said a couple times, please feel free to use the chat window to make comments. I may not be able to get to them, all of them, but we'll make sure we'll follow up with any questions that you might have. So let's go ahead and begin. Inspire Science is a comprehensive research-based program built to support three-dimensional instruction in your classroom. And so Inspire Science is built at the middle school level on units, 4 units per student per grade level. These are write-in consumable textbooks. What do I mean by that? I mean, students are actually writing in them. They're journaling in them. They're collecting their data in them because their labs are in these. And we replace these every year for every student, as long as you have Inspire Science in your classroom. At the high school level, it's a little bit more traditional, a hardbound student edition and a hardbound teacher's edition. For the AP honors and elective courses, we have, whether it's AP biology, AP chemistry with Chang, or the much beloved Holes Anatomy and Physiology, which is designed to be a semester course, a high school course for anatomy and physiology. We've got courses to support you. And all of the programs, grades 6 through 8, 9 through 12, AP honors and electives, all use the same online platform for remote and hybrid instruction. So this program is designed for both print, remote, or anywhere in between. Student print editions, teacher editions. It's developed and designed and proven to be successful in a digital classroom where students are having devices in their hands every single day, or anywhere in between. Wherever you're at, Inspire Science is designed to support you. And typically the next question I get asked is on what devices? Well, PC, laptop, Chromebook, tablet, and even smartphone. So as a teacher, you can create a test, let's say, on your desktop. You can send it to your students. They can take that test on their smartphone, send it to you for a grade, and then you can see how they scored on their tablet. Any device for teachers and students anywhere. What kind of experiences are they going to find on their devices? Well, a lot of different things. Since this is a phenomena-based program, you'll see phenomena at the module and lesson level, virtual labs and simulations, lesson concept videos, an adaptive personalized learning tool that we call LearnSmart. I'll talk more about that today. And then a dynamic ebook experience that brings it all together. There's even an app in Inspire Science. I don't know about you, but most every young person I see these days has a phone somewhere nearby, and we wanted to make sure students could access science in the way that they wanted to. So they can download chapters to their phone, they can access those chapters online, they can highlight that experience, and then once they're back online, everything syncs up, and all those highlights, all those annotations get synced back up into the experience. So we're meeting students where they're at. And I know this is on a lot of folks' mind. Will Inspire Science work with what we're using on our campus? And the answer is yes. We have a integration team whose sole focus is the successful integration of what you're using with what we're using in Inspire Science. So let's begin. Inspire Science is designed for three-dimensional learning. That's the integration of the science engineering practices, the core ideas, and the cross-cutting concepts in each and every lesson. So let me show you a little bit of how that looks like, what that looks like in 6 through 8, and then we'll transition to 9 through 12 and see how that's just a little bit different, but developmentally appropriate for our high school students. With Inspire Science, every module begins with an anchoring phenomena. And by the way, as I go through realize this, every single experience that I share with you, every reading assignment, every lab, every virtual experience can be assigned digitally to have students do on their devices. So every module begins with a module opener. And here it says, what conditions are needed for a substance to both freeze and boil? Go online to watch the triple point to see that phenomena in action. So what we're going to do is go online and take a look at that. So there is a condition where liquid nitrogen will both freeze and boil at the same time. It's called the triple point. Well, how is that possible? How can something both freeze and boil at the same time? Well, temperature and pressure has powerful effects on matter. And this module is all about exploring the effects of temperature and pressure on substances at a molecular level. So students get to see this triple point in action. Yes, something can freeze and boil at the same time. And then they go on their exploration for why is this taking place? How is this possible? And what effects does temperature and pressure have on matter. So every module will begin in this way, some sort of phenomena to spark curiosity and student-generated questions. It's a great opportunity to send this remotely, have students do it asynchronously, and then let's come back and share our thoughts in a synchronous situation, whether it be Zoom or through in-classroom instruction. From there, in middle school, we have a STEM module project launch. It's an introduction to the STEM module project that awaits them. It's either a science challenge or an engineering challenge. In an engineering challenge, they're designing a solution to a real-world problem. From there, Inspire Science uses the 5E lesson model, and this is true grades 6 through 8 and 9 through 12. It's a research-based approach, except Inspire Science has added one additional step, and that's Paige Keeley and her formative assessment probes. So who is Paige Keeley and what are her formative assessment probes? Paige Keeley is a former president of NSTA. She's a wildly successful author. You may have seen her Uncovering Student Ideas series, and she's known for creating these scenarios that students have to consider and talk about and think about and decide who they agree with most and why. This one is called Shrinking Bottles for this particular module. After the big game, on a hot day, you put a bottle of water inside of the refrigerator. That bottle's been outside in the temperature all day long. The next day you see that the water bottle has become dented. Which statement describes what happened? Is it A, the molecules left the water bottle? B, some air molecules were broken down? C, the air particles slowed down and got closer together? Or is it D, some of the molecules escaped the water bottle? Now the answers might be all over the place, let's say in the middle school classroom, but it's not necessarily the answer that's the most important part. It's the explanation. It's in that explanation that you're going to discover student misconceptions. And if I had you in a big room today, I'd have you broken out into groups of 2 or 3, and I'd have you share your thinking with your group. What do you think is happening and why? Explain your answer. You'll engage in some argumentation in this process, scientific discourse. You'll consider the ideas of your classmates, and it creates a great environment to launch a lesson. So it benefits both teacher and student. And we revisit the probes over time. So you can post a probe. You can see how students are responding at the beginning of the lesson. Here's the blue sticky note that marks the beginning of the lesson. This probe has A through G as possible answer choices. Looks like a lot of students thought A was the best answer. Certainly not all of them. A week into the lesson in purple, you see, boy, their thinking has changed quite a bit. They're pretty undecided and pretty evenly distributed. And here we see 2 weeks into the lesson. Now they've had some labs, they've done some research, they've really had experiences, and now they're starting to think D is the best possible answer. This mirrors the way scientists information. Even scientists change your thinking as they get additional information. In a remote learning environment, maybe you have students, you assign this probe, have students consider it, and then post their responses on a Padlet. That's just one way to use it asynchronously, and then we'll come back in a synchronous situation and talk about it. Every experience in Inspire Science, it has a mirrored image online. So instead of having this experience in a print student edition, you can assign it online and have students complete it online and send it back to you for a score. So as I go through this, and this is just a reminder, every experience I share with you, every singular experience can be shared and assigned for a remote learning situation. So uncovering misconceptions, engaging in argumentation, and a desire to know with teacher support along the way. When we get into the lesson level, we have a phenomena there as well. So what's going on here? This lake is thawing. What's causing it to thaw? What processes are taking place? Every single lesson in Inspire Science will begin with some sort of phenomena to spark curiosity and get students thinking about what's going on. From there, we use the claim, evidence, and reasoning framework. It's a feature found 6 through 12 with Inspire Science. It's a way for students to collect evidence, to either support or refute their claim and then make a reasoning statement to connect their claim with evidence. Every single lesson in Inspire Science integrates this framework. Now, when we're in classrooms, labs are pretty easy, right? We've all done labs, and Inspire Science has them in the Explore section of the 5E lesson model. And we also use kits if possible. So Inspire Science has provided these kits neatly organized by unit and module. But what about remote learning situations? How do we do labs when students are at home or in a hybrid situation? Well, with Inspire Science, we have those labs on video. It might be the next best thing. Maybe they watch the lab and read the lab and they can experience it at home. And then on the Zoom or Microsoft Teams meeting, let's talk about what they discovered, their findings, their conclusions. Do they agree with what the students discovered on these labs? So you'll see these experiences in Inspire Science to support you. As we continue here, for those labs that are too dangerous, too time consuming, too expensive to do in class, or for remote learning situations, how about assigning a virtual lab? Have students experience this, just like that video, and then we can come back and report back on the Zoom or the Microsoft Teams meeting. Many of you are using PhET simulations. Inspire Science is a partner with PhET. So not only is there a suite of McGraw-Hill virtual labs, and there are a bunch of them, there's also PhET simulations. You don't have to go to PhET to find them. They're right within the McGraw-Hill experience, assignable to students on our platform. When we get to elaborate, that E is always some sort of an extension into science and society, science and vocations, anything that's outside of the classroom that applies the science that you've been teaching. And in middle school, when we wrap up, we're in evaluate. That's the last E. We're going to revisit that probe. Remember, we revisit the probe and the student's thinking over time. We're going to see if we can explain that claim. We're going to finish the claim, evidence, and reasoning loop. Well, these two arrows are moving backwards, and one arrow is moving forward. It's telling students it's time to make a contribution to the STEM module project. So after every lesson, students are contributing to the STEM module project, which awaits them at the end of the module. And at the end of the module, they have that STEM module project that will be either a science challenge or an engineering challenge. Now, something that has proven incredibly successful for remote and hybrid learning situations is something called LearnSmart, a smart book. It's an adaptive, personalized learning tool. Now, when I use the word adaptive, I like to explain what that means. Think, because everybody has a different idea of what adaptive means to them. Think of Netflix and Amazon. The more you go to these sites, the more they're getting to know you a little bit better. Your likes, your dislikes, your preferences. Well, LearnSmart is doing the same thing. Students are reading and they're being asked questions. Notice there's a confidence component here. Not only are they answering what they think the best answer is, they're also sharing whether they have high, medium, or low confidence. All along the way, LearnSmart is collecting data on what students know and what they don't know, and it's prescribing a pathway to mastery. On the teacher side, you have reports that you could generate to see how students are performing, to see what their most challenging concepts are. But as a student, it's providing a pathway to mastery, and it's never giving them a chance to forget it. LearnSmart has proven to be a powerful tool in remote learning situations. When you get back to in-classroom instruction, a lot of classrooms are using LearnSmart for students to get the core ideas outside of class. They read, they're being assessed. Less classroom needs to be spent with that. We can open up some of that classroom time for some exploration, digging a little bit deeper, more hands-on experiences. So a lot of different uses for LearnSmart, and it's a part of the Inspire Science program. And why is it such a big deal? It's efficacy. So successful has LearnSmart been in our AP and college classrooms that we brought it down to high school and even middle school. It's an Inspire Science exclusive. So let's see some of the ways we've designed the program to inspire your students. So by that, I mean making connections to as many students as possible. Well, we do it through the visual learners. What percentage of us are visual learners? Well, research says about 65% of us are visual learners. We're the ones that dream in color, circle, highlight, underline words. We always gravitated to those resources and images and visuals that helped us make sense of the narrative. So not only are you going to see phenomena videos like the one you see on the right, that's a pretty interesting phenomena. You're going to see concepts in motion videos. Brain pop videos are a part of Inspire Science. And on the bottom right, you see what we call a personal tutor. And Mr. Travers is walking students through a lesson on epicenters. The nice thing about Mr. Travers is he's just excited to go over this the 20th time as he is the first time. He never gets tired or frustrated or angry on a bad day. There are male and female voices. It's not always Mr. Travers. Mr. Travers has colleagues, and we've designed our personal tutors to hopefully be the next best thing to you when you're not around. Look for these experiences 6 through 12 in Inspire Science to support those visual learners in your classrooms. Now, continuing, animations are found in the elementary school classroom or the middle school classroom, not in high school, but we have them in middle school. And why do we have animations, and what are their utility? Well, animations can show things that photographs, conceptual illustrations, even videos cannot. They allow you to dig beneath the surface, peel back the layers, and show the processes that are taking place underneath. So animations have a lot of utility in a science classroom, and we wanted to make sure we provided these experiences in the Inspire Science classroom. As we continue, let's take a look here. Here we go. Many of you have seen these, and these are foldables. Many of you have used foldables. For those of you that are not familiar with foldables, they're three-dimensional graphic organizers from Dynazyke, and we've been partners with foldables for about 20 years now. And in that time, foldables have become the most successful graphic organizer system in the world, and they're integrated into Inspire Science, and a great way for students to take notes in a remote learning environment. Students that use graphic organizers outperform students that do not. So let's transition to see what have we done in Inspire Science for you. Let's just take a look at a few things. Well, all of these experiences that I've shown you, all the labs, all the simulations, the probes, they're all part of a pre-made presentation that you can customize and have students access remotely or in a hybrid situation. What about students that miss class or at home sick, or if they're still in remote learning situations? How about customizing the lesson to be exactly what you want students to experience and have them experience that on their device anytime, anywhere? So you may not want to use this lab, and maybe you don't want to use this reading. Get them out of the presentation and have students only see what you want them to see. And then finally, a test generator. Create a test in seconds, customize it, add your own questions, just make it perfect and print it out. Back when we get into our classroom, you can make copies. But now that we're in a remote learning situation, maybe have students do it digitally, assign it to them. Have them complete it, and once they complete it, they could send it back to you and it gets scored automatically. And you could generate reports to see how students are doing. Inspire Science, since it's a three-dimensional program, has also incorporated three-dimensional assessments. We've partnered with Measured Progress, a company that's sole focus is designed to prepare students for the assessment that awaits them. So you'll see assessments at the depth and the rigor that you want them to have. Guided practice is the first part, and there is a 3D coach, kind of giving them a hint, pointing them in the right direction. Once they get past guided practice, they're into practice. The coach disappears. So think of it as sort of a gradual release method. And finally, they're going to have performance tasks and unit tests. And every one of these is either printable, or every one of these test items is printable or assignable digitally. If you're still in a remote situation, they can work that way as well. So a lot of what I've shown was for middle school. PhET simulations are for high school, virtual labs are for high school, but let me zero in on some things that are specific to high school. And what is this? Well, you might be asking, why am I showing this beach? Well, I went to this place in 2015. This is Cancun, Mexico. And I heard about the beautiful beaches in Cancun. And oh, I was so excited to go to them. Boy, I can't wait to get to these beaches I've been hearing about. But when I got to Cancun in 2015, it didn't look like this. It looked more like this. Sargassum bloom was everywhere. It was on the beaches. It would get into your swim trunks. It smelled. The hotels couldn't get on top of it. They tried to bury it, but they just couldn't. There was too much of it. So the science teacher and me started thinking, well, what's causing this? How can we solve this problem? How can we stop it at the source? And if we can't stop it at the source, are there solutions that we can do after the fact? Like, can we have a food a solution for this? Can we use this for fuel? Can we make building materials out of this? Well, it just so happens Inspire Science has a STEM project for that in high school. It's an NGSS aligned STEM project. Students are going to try to solve this problem. They're going to research it. They're going to use the engineering design process to come up with a creative solution to that problem. They're going to consider the limitations, things like cost, environmental issues, the pros, the cons. They're going to revise, refine, and then finally communicate their solution to the class. So STEM module projects not only are a part of 6-8 Inspire Science, they're a big part of high school Inspire Science as well. Every unit has one. Many teachers in classrooms these days are using a driving question storyboard, especially NGSS classrooms. Post the driving question board up and have students generate their questions and post them with sticky notes. So we have these in Inspire Science. They're integrated in each and every module. And students can post what they're thinking. And if you're in a remote learning environment, how about using a Padlet? Have students consider the driving question, post their questions on a Padlet, and then we can revisit it in a Zoom or a Microsoft Teams meeting. So all along the way, students are using this to collect evidence and support or ask additional questions based on that phenomenon. So whether it's the color coding found in Inspire Science, whether it's the Page-Keeley probes, which by the way, we have for high school as well. Let's take a look at one. Here's one for high school. We saw the one of the bottles in middle school. Here's one for physics. Does it describe both magnitude and direction? Some quantities in physics describe both magnitude and direction. Which of these statements describe both magnitude and direction? How about a car driving at 60 miles an hour? Does that describe both magnitude and direction? How about wind coming from the northwest at 20 miles an hour? How about a person pulling a dog leash? A picture hanging on the wall with two wires. Students have to decide which one of these describe both magnitude and direction and explain why it does. Again, these probe experiences are designed to uncover misconceptions, get students talking, accessing prior knowledge, and get them thinking about phenomena. So whether it's the color coding, the probes, or the driving question storyboard, all of these are best practices. Every lesson or every module in high school begins with a phenomena just like we saw in middle school. We saw the triple point in middle school, but here's one for high school. Could a person really sink and disappear into quicksand? Boy, this person looks like he's in a fix, but he doesn't seem to be too bothered by it. Let's see this phenomena in action. So it says, go online and watch this video. So that's what students will do. They have a video on phenomena. Let's take a quick look at this one. They're going to try to pull this dummy out of the quicksand. They're going to use a lift. They can't do it by hand, so they get some mechanical advantage.
Has some serious power. It's normally used for lifting 10-ton skips, so hopefully it's got enough oomph to get our dummy unstuck.
This experiment. So the quicksand is exerting a tremendous amount of force. They're unable to pull it out. So every module in high school, just like in middle school, will begin with a phenomena of this kind. Whether you're a physics teacher, chemistry, earth science, all of them will begin with phenomena. You'll see claim evidence and reasoning integration in high school as well. But just like middle school, Inspire Science is built on hands-on learning, quick investigations, data analysis labs, real-world biology labs. So think quantity, quality, and variety of inquiry-based experiences, including forensics labs like this one. How do you find patient zero? Something that's pretty timely these days. Students have this whodunit CSI type mystery. And then a couple other resources that can be used for remote learning or in-class instruction are the reading essentials in the science notebook. On the left-hand side, you see the student edition. On the right-hand side, you see the reading essentials. Same heading, same sequence, but it's a write-in version of the textbook. It also has more white space, a little bit larger font size, a little bit aesthetically more accessible to more students. Most powerful part of the reading essentials is that it's written 2 to 3 grade levels below the student textbook. Another resource that can be used remotely or in class or is a science notebook. You probably noticed this look. That is the Cornell system for notes. Main idea on the left, keep it very clean, just the main ideas. Indent and put the supporting detail. So for every single day of instruction, you have that support for you. And really quick, I know I'm out of time. I just want to show you one more thing here. I said to you earlier, every single experience can be assigned remotely, and that's true. Every single experience can be assigned remotely, even reading assignments. So maybe you don't want to assign pages 15 through 35 as a lesson. Maybe a smaller chunk of information is more appropriate. So you can. So we've broken down every part of the student edition into smaller chunks. Here's high school biology. So maybe I just want to assign this part of the high school biology lesson. And if I assign it, take a look at what students have. They have experiences like widgets that support them all along the way. There's little interactives that they can interact with. So I have a plasma membrane, microfilets, microtubules. Let me take a look at all levels. And then at the end, there's some self-practice, and there's a quiz that students can use to be scored. And to assign it in a remote learning situation, it's as easy as clicking assign, giving a due date, deciding the instructions. I'll just say complete and return. And then deciding how many points you want students to, and then deciding who gets it. And when I click assign, that's been assigned to my students. It will show up in my calendar. It will show up in my assignments list as something that I've assigned to students. So assigning in the OLP platform is what we call it, is an extremely easy experience. And every single, why it's been so successful in remote learning situations is that every experience can be assigned in that way. Every lab, every virtual lab, every reading assignment is broken down into these nice handy little chunks that can be assigned by you as a teacher. So everything that I've showed you, and I know it's been a lot in a short amount of time, it's development. And that's online, on demand, anytime, anywhere. But it's also on site. You have an incredible team there in your area to support you, whether it's program professional development or something a little bit more customized to meet your needs. Let us know how we can support you. Inspire Science was designed to spark curiosity, investigation, and innovation, and help students explore their phenomenal world. So I'm here to answer any questions that you might have. Let me take a look at the chat. Suresh, are you up here?
You discussed such important aspects of online learning that I wasn't aware of. So the guided practice was new to me. The test reports was very interesting, and as well as the Padlet. I guess I knew the Padlet, but we didn't really use it as much when we were in classrooms.
Yeah, true, very true.
But yes, thank you so much. If you have any questions, I know some new people have joined us. Welcome. This is the Inspire Science session. You're in the right place. For those of you who have completed the session, just dropping the link to the math breakout room. So you can enter the math breakout room now. If you'd like to, any questions for Jason before we start this session? So this is going to be a repeat one, by the way. You will have to switch the room. You will